I'm Melissa.
And I'm Jam.
And I'm a chemist.
And I'm not.
And this is Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
Jam, we're in a new space today.
I know, it's kind of weird.
It's very weird.
Do we sound different?
Yeah, listeners, let us know if you can tell that we're in a new space, if you can feel a different vibe.
Yeah, let us know. We are now in Melissa's office at the university. And yeah, it's kind of interesting, but cool. Feels a lot more chemistry-y.
Definitely more chemistry.
That's for sure. There's all kinds of really dangerous chemicals around us right now.
That's absolutely not true. The only kind of, well, it's not even, there's chemistry and everything, but the only liquid chemical I see right now is honey. So, but there is a cool puzzle of the periodic table.
And a lot of cool chemistry books and whatever that kind of thermometer thing over there is.
Galileo thermometer, very cute.
Yeah.
Okay. So we're in a new space today, but you're still going to be learning. I'm going to teach you something.
Okay.
You're going to explain it back to me.
Okay.
Just like always.
Deal. I'm in.
Okay. So this week, you're going to be learning about hair.
Whoa. Okay.
Why is some hair curly and some hair straight?
So there's a chemistry, obviously it's biology too, but it's chemistry?
There's chemistry in everything.
That's cool. I'm in.
You're in, you're ready to go?
Yes, my hair is insanely straight. Mm-hmm. And it's very fine too. Each strand of hair is not very thick. So I've always been pretty interested in that, and also always wished that my hair did something. It is just lays. It's lazy.
But when it does something, it doesn't usually do it the way you want to do it. So my hair is very curly.
Uh-huh.
I have lots of weird, almost like cowlicks, but it's just the way the hair grows all over my head.
Uh-huh.
That it wants to go whatever direction it wants to go in.
Yeah.
It can look amazing, and then I walk outside into the wind or humidity, and it instantly looks totally different than it did before.
Man.
So don't wish too hard for your hair to do something. Just be thankful for what you have.
I am thankful. I know there's a lot of benefits. People spend a lot of time straightening their hair. My hair is super straight no matter what I do. But it's just I wish I would just do something, you know?
Yeah. Don't wish for that. But I've come to really like my curly hair.
Yeah.
Because I can basically wash it and leave it, and it will still look okay.
Yeah.
But I am very active in the curly girl community, trying to figure out the best way to manage my curls. So any curly girls out there, check out the Curly Girl Handbook.
There's not really a comparable group for straight guys in the hair way. So I don't really have a group.
Oh, that is kind of sad. I have a whole support team that's excited about curly hair.
But there's not really groups for guys for hair as much anyway. So that's...
are definitely guys on the Curly Girl.
I can see that.
They've changed it to just curly hair community.
Yeah, that's a good idea. I mean, I feel like if you had a curly hair guy community, there'd be a lot of dudes being just asking, what do we do? And not having any good advice to share. Unless they got it from girls.
Their curls look really good a lot of times. So we're going to talk about curly hair. That was a long intro. We're going to talk about curly hair.
Uh-huh.
But first, to talk about hair, curly hair, straight hair, we have to talk about hair in general.
Okay.
So hair is primarily made up of a protein called keratin.
I knew that. I don't know where I learned that, but I had heard that somewhere. And it's the same thing as fingernails, right? Mm-hmm. Whoa.
And keratin is made up of a series of amino acids. Any protein is made up of long chains of repeating amino acids.
Okay.
They're just bonded together. And usually because of the intermolecular forces or possibly other bonding that goes on, proteins can fold in on themselves and have a specific structure.
Okay.
So we see that in the DNA double helix structure. That is as a result of hydrogen bonding, which we talked about in the what is a scientific word for sticky episode. That's episode 11.
Uh-huh.
So because of intermolecular forces, things like proteins can take shapes.
Okay.
So in the case of keratin, it has one specific type of amino acid. All an amino acid is sort of like we talked about in the What Makes Toast Toasty episode about the Maillard reaction.
Yes.
Is this special type of functional group.
Okay.
And a functional group is just atoms arranged in a specific way.
Okay.
So an amino acid is a special type of functional group,
Okay.
but the different amino acids have different arrangements of atom attached to that functional group. So say they all have the same part A, but their part B can be switched out.
Mm-hmm.
So there's different types of amino acids.
Okay.
That's all an amino acid is.
Okay.
An amino acid that is present in abundance in keratin
Mm-hmm.
is cysteine,
Okay.
and cysteine has a sulfur group on it. So we're digging into the nitty gritty here, but it's all relevant to curly hair, I promise.
Okay.
So we've got our keratin,
Uh-huh.
which is the protein present in hair. And that protein has the amino acid cysteine
Uh-huh.
that is present throughout it.
And cysteine has sulfur in it.
Cysteine has a sulfur atom in it.
Sulfur atom in it. So it's not like it's like straight up sulfur, but there is some sulfur in there at the atomic level.
Right.
Got it. And I think I remember from like basic bio stuff and chemistry stuff that proteins, I remember just being like the definition of it was like, or one of them was like, it's made up of amino acids.
That's exactly right.
Even though I don't remember a lot of the other details, at least that I kind of remember as you started talking about that.
Right.
So that's helpful.
Maybe kind of common knowledge, but just in case.
Yeah.
All you really need to know is at the very basic level, proteins are made up of several repeating units of functional groups.
Okay. Got it.
Slightly differently functionalized functional groups, but they're just repeating units of atoms that have special structures that fold in on themselves.
Okay.
So that's all proteins really are. Everything's organic chemistry. So the special thing about these sulfur bonds
Okay.
is that they can bond to each other. So in DNA, the thing that forms the double helix shape of DNA is a intermolecular force, not a true bond.
Okay.
But two cysteine amino acids that are near each other can form what's called a disulfide bond, which is quite literally, just a bond between those two sulfurs.
Okay.
So it's possible that one of those bonds will form with another sulfur group between two sulfur groups a little further down the hair shaft, which makes a little bend in the hair. And the more of those little bends in the hair, the more curly our hair is.
Interesting. Okay, so when the sulfurs bond, that's when there's a curl? Say it again. I think I missed it. Or a kink or whatever.
So my understanding is the sulfur bonds are present, disulfide bonds are present throughout hair.
Okay.
But they are responsible for setting the hair in its shape.
Okay.
So if it's straight, I believe the disulfide bonds are closer together and they're not forming that kink.
Uh-huh.
And if they're further apart, then it's almost like the rest of the proteins kind of have to bend to let those two sulfurs meet.
Oh, weird.
So instead of a ladder where the sulfurs are all bonded in a row and it sort of keeps the hair nicely lined up, it's more like a U shape, and the two sides of the U have to come together for those two sulfurs to touch.
Okay. That's so crazy. And it has a way that it wants to be doing it. So my hair being straight, your hair being curly. My straight hair is trying to do it straight up. Very like simple.
Sulfur bonds are
Straight.
probably bonded to other sulfurs very close to them.
Okay.
Not further away.
And for some reason, even from the root of my hair or whatever, it wants to do it that way.
Yes, well, actually,
Uh-oh.
it all has to do with the shape of the follicle of your hair.
What?
If the shape of the follicle of your hair, I did not know this.
Uh-huh.
I had learned about the disulfide bonds in organic chemistry a long time ago, and I had never looked further into it. But if your hair follicle is perfectly round, there's less opportunities for those disulfide bonds to form further away. But if it's slightly oval shaped, the disulfide bonds can form to make those little bends.
Interesting. Okay, so it's not like our hair is thinking, I want to do it this way. It's like the shape of something has a very natural effect. The shape of the follicle has a very natural effect on those bonds.
Yes.
And how close or far apart they are from each other. I like that because otherwise it is confusing to be like, like, why did my hair want to be like this?
Yeah.
And like we talk about like traits of hair, like having kids and, oh yeah, I got my, dad's hair or whatever.
Right.
That kind of stuff. But it's not really the hair itself that we got. It's like the follicle shape is it.
That is my best understanding, is that it's the follicle shape that allows for the bonds to form that make your hair curly or straight.
Interesting.
Mm-hmm. There's a really nice phrase of the description on one of my sources. It's called The Science of Curls. It's by Dr. Leda Marie Tirado Lee. I probably butchered that. I'm so sorry. It was linked from an ACS website, so I know it's credible. She has a PhD in chemistry.
Mm-hmm.
And she says, curly hair has more of these bonds, referred to as disulfide bonds, than straight hair because the follicle shape and angle allows different regions of the hair to come closer together, making these bonds easier to form.
Wow.
Yes.
That's crazy.
I know.
And the bonds, okay, wait. This is a question. Are the bonds even necessary for a hair's like makeup at all, or is it just an incidental thing?
That's a hard question to answer.
Like our hair is not going to fall apart without those bonds, or is that what was keeping it together?
We'll talk about this more next week.
Okay.
I already have a plan to sort of talk about the many layers of the structure of proteins.
Okay.
And how that plays into damage, how that plays into straightening our hair and perming our hair.
Okay.
But for this week, I think all I should really say in response to that question is the sulfide bonds form naturally as a result of these two sulfur groups that are near one another. And these sulfur groups are key to the cysteine amino acids that are key to the keratin that makes up our hair.
Okay, so it is important. It's part of it. It's got to be there. But it's not like the main thing.
I almost feel like that's a chicken or the egg kind of question. I don't know what would happen if you change those sulfur groups to something else. Maybe hair would look totally different.
Classic question. Which do you eat first, the chicken or the egg? One of those philosophical questions we've always...
Yeah, that's the classic question.
Yeah, it's hard to decide.
So that's a tough question because it almost is saying, does this happen as a byproduct of the sulfur being in there? Or is hair this way because it's evolved? That's just a bigger, deeper question. But we will talk about what happens when you mess with those sulfur bonds next week. So you're almost just jumping ahead.
Okay, sorry. Didn't mean to jump ahead.
So I guess I'll forgive you.
Today somebody asked me, what are you guys going to talk about today when y'all record? And I said, I have no idea. And even we talked about that, I think not everybody thinks it's really true. But like many times, other than like when we had a guest and we had to plan for that a little bit differently, many times I do not know anything about what we're going to talk about.
Big surprise.
Yeah. But now I do for next week, I guess.
So that's it. That's the main things I wanted to get across to you today.
Okay.
I wanted you to know that everything about the way that your hair looks is chemistry.
Okay.
In terms of texture, but also really in terms of color. But we'll just stop with texture today.
Okay.
And some of the very basics of what bonds form, curls versus straight hair. And that the shape of your follicle has everything to do with it, allowing the bonds to form or not.
Okay. Wow. Okay. So.
Is this not amazing to you?
It is, but I'm like, I'm not sure I get it yet. Okay. That's what we'll find out, I guess, when I say it back to you. But it is amazing to me. I have known nothing about hair at all, ever, other than the fact that keratin is a word that I've heard used to describe about what is made of. I didn't even know what keratin was, so it didn't really mean anything to me. So like, this is all 100% new to me.
That's so exciting. I'm so excited I could teach you something new.
So, shall I?
Please do.
So, everybody's got a head for the most part. And on our heads, there's follicles. And the follicle is just where the part where the hair is made, grows out of or whatever. Apparently, it can be shaped different ways. as I'm finding out today. And depending on its shape, as it grows, what is growing is the protein keratin.
Yes.
Keratin is made up of, or any protein is made up of amino acids. The amino acids that make up keratin are cysteine, is what they're called.
There are other amino acids too, but cysteine is present in abundance,
Okay.
is my understanding.
Okay.
I'm not a biochemist, so if there's a biochemist who knows more, I'm always open to information.
So, but cysteine is kind of the one that has the main effect that we're talking about
Right.
curly and straight. And it's definitely very, very present in hair.
Right.
Not necessarily like the only thing. And cysteine has sulfur atoms in it. And
One sulfur atom.
one sulfur atom in
and a
it
cysteine amino acid.
per acid.
Right.
And those sulfurs want to, just like other things want to bond to other stuff, they want to bond to other sulfurs. And because there's one, it's lonely. It's like, man, this sucks. And it's like waiting in a line alone. And so when you're waiting in a line alone, you wish you had a buddy. Especially like lunch line, remember cafeteria back in the day?
Oh, yeah.
So if you have the opportunity, say the line doubles back like a queue, if your friend is in the section behind you and you guys get to meet up, you want to talk to your friend.
Right.
So as hair is being made, being pushed out from the follicle, depending on its shape, the line, say like the Q or whatever, can be slightly different shape as it comes out. And then those sulfurs that don't want to be on their own might have to try different things in order to not be on their own. If the line's super straight, then they don't have as hard of a time and they can be just right next to a buddy. If it's weird and curly, then you have to, the line has to do certain things to meet another, this analogy's falling apart, to meet
actually,
another
I think
sulfur.
the analogy was super good. The only thing I would change about your analogy is if a line's super straight, it doesn't have a lot of opportunity to meet people further back in the line.
Right. Yes, it doesn't. Right. It's just a straight line.
Right.
Going
and
on
so
forever.
there's not going to be those bonds forming across two different parts of the line.
But if the hair, the line is coming out in a non-straight way, even if it's like a only slight curl,
Right.
it has an opportunity to be where you could see somebody else on the line if it curves around. See your buddy. Oh, hey, I haven't seen him in years. I haven't seen him since college.
And change the shape of the line.
And change the shape of the line. And then you're talking, you're holding up the line, you're kind of affecting things a little bit, which is a little rude, but you're glad to see your friend. You haven't seen him since college. He actually has 2 kids now, and they actually moved to Connecticut, which you've never been to.
Do you have a specific person in
You
mind?
can't remember
right
his
now?
wife's name for the life of you, but you can't rudely look on Facebook now because you're talking to him, and then the hair gets really curly.
That's surprisingly a good analogy. That is actually a very good analogy. And actually, I think I'll be able to draw a picture to demonstrate the way the bonds form to kind of make the curls,
Right.
as opposed to the straight line. So if you're having a hard time visualizing,
Yeah.
we're going to put visual aids up.
That helped me too, I think, because a cue, a line is the only thing I could think of in terms of actual people, which I know is not perfect probably, but
Actually, I'm amazed by that analogy.
it gave me like something to look at because I just can't really visualize what hair looks like down at that like molecular level.
Right.
But so shape of follicle, it comes out a different shape. The bonds are trying to happen, so they're going to affect the shape too, whether it's straight or curly, and that's how our hair is how it is.
Yeah. Isn't that amazing?
Yeah, that's crazy. There's a lot more going into that than I would have ever thought. Like
Right.
so much of the world, I mean, if we could look at every single thing at a very, very detailed level and understand it, we'll probably be this everywhere we look. But so much of the world just seems like that's how it is. You know?
Right.
Like, oh yeah, your hair's just curly. Sorry. That's what it is. Oh, your hair's just boring and straight. Sorry, that's how it is. And most of us, including myself for most things other than when we talk about something on this podcast, just like that's the way the world is, and it doesn't matter if I understand it or not. And sometimes I just think there's not a way to understand it. Like, it doesn't really cross my mind that like I could understand hair better, or maybe it just seems like a lot of work, or where would I even find out? But yes, it's just how hair is. I had to get new tires on my wife's car the other day. I was like, this is just how life is. There's nothing I can do about it. Tires don't last forever. And I'm just floating along in this life that I don't get to make any choices about for a lot of those things.
But now you can understand this one thing.
Yes. I can at least hold on to this one thing next time I'm waiting for tires to be put in my wife's car for a long time.
So I was amazed about the hair follicle thing. I could not believe it makes so much sense. The shape of the follicle just controls physically whether the hair can come into contact with itself in such a way that allows curly silver bonds to be made while it's growing. And those bonds are very firm and stay in place. That all is so logical, but it never occurred to me. So I was amazed by that.
Yeah, I too am amazed, but I didn't know any part of it. So it's all new, including the follicle shape part.
Well, but there's more.
Whoa.
So I was looking into this. I found some really cool references, including one called The Chemistry of Hair from 1960. Super fun. I love old school science papers.
So they had hair then. Okay.
They did have hair in 1960.
Very cool.
I know, it's hard to believe. But there's also a lot of information on why straightening or curling your hair with a hot iron works, how it works, why your hair starts to look damaged, which blew my mind, and how perms work. Your wife got a perm.
I remember that.
Recently.
Yeah. It was about 2 years ago.
I thought perms were out, but they are not. So now that we know about why some hair is curly and some hair is straight, next week we're going to dive into how we can use science to manipulate and understand what's happening when we style our hair.
Okay. I'm in. I don't do a lot to style my hair, but I definitely know what you're talking about, and it'd be very interesting to understand how and why.
I'm so excited.
That'd be cool. Man, hair. Who knew?
Who knew? Science is in everything. Well, thanks for coming and learning about hair and listening to me teach you about sulfur bonds here in my office.
Anytime. And this is where we're going to be now for the foreseeable future.
Very exciting.
So, yeah.
Is there something happy this week that you want to share, or something that you would like to share about your life with the listeners?
So I'm going to cheat and say two things, sort of. First, I finally got over myself and watched The Mandalorian, or started it.
Still haven't done that.
Well, it just, I mean, no pressure, but together, even though you haven't started it yet, we're just behind. Even though I just started it. The culture has been doing this. They've been talking about it. I'm behind. You're behind. Doesn't matter. Even if I finish it today, I'll still be behind because everybody's been talking about it for longer. It is very good.
Oh, that's exciting.
It's what we all hoped we'd get, this kind of story with this level of storytelling with even the movies. And I think it's kind of better.
Wow.
It doesn't have any lightsabers or Jedis, but it's in the universe, and I love Star Wars. So
I have seen the Baby Yoda things.
Yeah.
But I've just been watching Brooklyn Nine-Nine, so.
Yeah. But so that's one thing. A much more meaningful thing of my life is that I got a Kindle because I wanted to be able to read more, and I'm hoping that will help me. And also, I like that it means I can read ebooks but not be distracted by like getting texts and stuff or whatever.
Yeah.
And it's nice. I mean, it feels like a book. Not feels in my hand, but like my eyes feel like I'm looking at a book, not like a screen.
Right.
Which is the whole point. I'm not like, it's not like they did it on accident or whatever. Like, wow, I can't believe they accidentally made it look like but so I like that. Hope I'll be reading more, and that made me happy.
That's so exciting. I'm glad you'll be reading more.
Me too. How about you?
Keep us posted on your books coming through.
I will. Man, I just
That'll
told
be
the
fun.
world I'll be reading more, and now I better follow up on that.
Accountability. Well, my life is pretty even keel. School started back up. I love my students. I'm excited to get some time with them again. Really like my program, everything that I'm doing in school. But I think the thing that's I'm most thankful for, that's most prominently going on in my life right now, is my mom had some surgeries that she had to do over the holiday break. And she's healing up really nicely from those. There's some follow-up stuff that's going to have to happen. But for right now, she's doing pretty well, and just I've had the opportunity to see her more and be around her more.
Yeah.
And in a way, that's been really nice. I'm glad that my program is such that it allows me to be with my family when they need me. And even just seeing her and my nephew more and my dad is just kind of like almost a neat silver lining of an unfortunate surgery situation.
Yeah, absolutely.
So that's my biggest thing going on.
I think that's very good. Good that it went well. And it is nice to have the kind of side benefits of getting to be around people more, even if the main reason that it's happening isn't the best.
And I got my mama Roku, and she is killing it on utilizing her free time.
Yeah.
So that's been fun too.
That's very good. She's getting in on the pop culture stuff that.
Oh, absolutely. I made her a list of all the things I think she'd like, and she's working her way through it.
Nice. That's so crazy. I don't know if I could get my mom to watch the stuff that I like to watch. So
a lot of it
I haven't tried really, but
like Psych, which she already liked a little, and I'm like, oh, now you can watch all of it, or just different things that she'd like.
Yeah, that's cool.
So that's what's going on with me.
Sweet. Well, that's all for today. Melissa and I have a lot of ideas for topics of chemistry in everyday life, but we want to hear from you. So if you have any questions or ideas, you can reach out to us on Gmail, Twitter, Instagram, Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share thoughts and ideas. If you enjoy this podcast, you can subscribe on your favorite podcast app. And if you really like it, tell one friend about our podcast this week. Just one. And if everybody did that, we'd have a lot more listeners. But especially if you're telling people who you think would really like chemistry, those are our people. We want to help people love chemistry, like Melissa loves chemistry, and like I am beginning to love it.
I really do love it so much, and my whole mission is to just get others to see the beauty of chemistry.
If you'd like to help us with that mission and keep our show going and contribute to the cost of making it, you can go to ko-fi.com/chem for your life and donate the cost of a cup of coffee.
This episode of Chemistry for Your Life was created by Melissa Collini and J.M. Robinson. References for this episode can be found in our show notes or on our website. J.M. Robinson is our producer, and we'd like to give a special thanks to A. Kiwasong and V. Garza, who reviewed this episode.